What if we could dig beneath the desert sand? What would we actually find? Believe it or not, it's way more than just dry dirt. Take the Sahara, for example, covering over 3.3 million square miles. Scientists believe it hasn't always been a barren wasteland. Hidden beneath its endless dunes are traces of ancient forests, long-lost lakes, underground caves, even evidence of a prehistoric ocean. And that's not all. There are signs of extraterrestrial visitors and a mysterious type of glass that scientists still can't fully explain. But before we start digging, we need to ask, where does all that desert sand even come from? Think about it. Earth is a rocky planet. In the desert, daytime heat can soar above 140 degrees Fahrenheit, baking the surface. Rocks expand like bread rising in an oven. Then, at night, with no clouds to trap the heat, temperatures can plummet below freezing, causing those same rocks to contract. This constant cycle of swelling and shrinking goes on for millions of years. Eventually, even the toughest rocks start to crack, crumble, and break down into gravel and grains of sand. And that's where the wind steps in. Acting like nature's delivery truck, it blows the sand into massive piles. Over time, those piles grow into dunes, some towering more than 600 feet high. And when countless dunes connect together, you get the endless seas of sand we call deserts. So, when we start digging into the desert, the first few dozen feet are usually just loose sand. Of course, the depth varies. Some deserts are only a few feet deep, while others stretch down several stories. But before long, your shovel would hit something harder, a crust known as caliche. This layer forms when sand gets compressed over time, glued together with tiny amounts of water and minerals. Imagine a giant, rock-hard cookie buried under the dunes. That's the first barrier to the desert's hidden world. Break through it, and you'll strike solid bedrock, the foundation of the desert itself. And here's where the Sahara begins to reveal its oldest secrets. In 2016, scientists analyzing space shuttle radar data discovered something incredible beneath the sands of eastern Sahara. A prehistoric super lake formed about 250,000 years ago. At its peak, Lake Megachad stretched over 40,000 square miles, once nourishing plants, animals, and even early humans. But it lasted only a few thousand years. Evaporation outpaced rainfall, and eventually, the entire lake was swallowed by the sand. Dig deeper, and you may stumble upon marine fossils. That's because millions of years ago, this land was covered by the ancient Tethys Ocean. In Egypt's Valley of the Whales, paleontologists have unearthed massive Basilosaurus fossils, giant whale-like creatures that once ruled these waters. Later, tectonic shifts lifted the seabed into dry land, leaving thick layers of ocean sediment behind. And if you're lucky, you might even uncover dinosaur bones. During the Cretaceous period, the Sahara was a dinosaur paradise. Fossils of enormous sauropods have been found here. Plant eaters stretching over 100 feet long and weighing up to 60 tons, among the largest creatures ever to walk the earth. But the Sahara's mysteries don't stop with Earth's history. Scattered among the dunes is a strange material known as Libyan desert glass. It's 98% pure silica, resembling shattered greenish glass, and it dates back nearly 29 million years. In fact, a scarab carved from this glass was found on King Tut's necklace. The real mystery? To form, it would have required temperatures over 3,000 degrees Fahrenheit, far hotter than any natural volcanic process on Earth. Most scientists believe it came from a cosmic impact. Yet, for years, no crater was ever found nearby. That changed in 2007, when researchers discovered a 19-mile wide impact crater about 60 miles from the glass field's evidence that something from space once slammed into the desert, leaving behind this extraterrestrial signature. So what about the Sahara's future? Could it ever turn green again? Scientists think so. The Sahara's green periods are linked to tiny shifts in Earth's orbit that happen roughly every 23,000 years. These changes alter monsoon patterns, bringing heavy rainfall that transforms the desert into grasslands and lakes. If the cycle holds, about 10,000 years from now, the Sahara could once again be a lush paradise. But human activity is changing the game. Greenhouse gas emissions are disrupting the climate, potentially breaking this natural rhythm. Which means the Sahara's fate isn't just written in the stars, it depends on us.